Let's work the following problems. Let's make these conversions involving the metric system, the SI system, and prefixes. Before we do each conversion, let's mentally estimate the approximate magnitude of our answer. Will it be a large number, or will it be a number that's a fractional number less than 1? If you haven't memorized the SI units and abbreviations, you need to stop and do so. If you haven't memorized the prefixes, their abbreviations, and what they mean, you need to stop and do so. M stands for meter, the unit for length, and D is the abbreviation for deci, which means 10 to the minus 1. And so, which one's larger, a meter or a decimeter? The meter is. So we're going to need lots of decimeters to equal a meter. So our answer, as we estimate it, is going to be a number that's greater than 1. Let's use the factor label method or dimensional analysis to solve this problem. So I'm going to take my quantity to be manipulated. I'm going to multiply it by a conversion factor. And when I do so, I want to write it so that the meters will wind up canceling out, and we'll wind up with units of decimeters. Now comes the tricky part of getting this conversion factor right. What we're really doing is multiplying that 1 meter by the number 1. It's some sort of identity, so that we're not changing its true value. So where does the 10 to the minus 1 go? Well, it's 1 decimeter is the same as 10 to the minus 1 meters. So 10 to the minus 1 goes with the meter. It does not go with the decimeter. If you do that, you're going to be off by not just a factor of 10, but a factor of 100. We do the multiplication, meters cancels. We're left with the units of decimeters, and the answer is 10 decimeters. Next problem. 1 meter is equal to how many centimeters? Where C is the abbreviation for centi, which means 1/100th, or 10 to the minus 2. So which one is larger? A meter, which is roughly 2/3 of a yard, or a centimeter, which is a fraction of an inch? The meter is larger. And so we're going to take lots of centimeters to make a meter. So our answer, we're going to estimate, will be a number that's greater than 1. Let's use dimensional analysis, or the factor label method, once again. We'll take our original quantity, multiply it by some sort of conversion factor. We want to write it so that meters will cancel and that we'll be left with centimeters. So it's going to be centimeters over meters. Now where do we put in the 10 to the minus 2? Yes, centi means 10 to the minus 2, but we don't multiply 10 to the minus 2 times the centimeters, because otherwise you're really making that be 10 to the minus 4, because centi itself means 10 to the minus 2. So where the 10 to the minus 2 goes is with the meter term. Meters cancels. We're left with centimeters, and it will be 100 centimeters is our answer. Our answer's got a magnitude, and some units. So whenever you finish working a problem, make sure you've got a number that has the correct units, we do, and that the answer makes sense. We oftentimes can do a ballpark estimate. We said the number ought to be greater than 1, and 100 is certainly greater than 1, so that answer makes sense. We would come up with 1 times 10 to the minus 4 is the answer, then hopefully you would realize that something's gone astray and you need to go back and figure out where you went wrong. The last one. 1 meter is equal to how many km? Well, K is a prefix. It means kilo, which means 1,000. So which one's larger, a meter or a kilometer? Well, a meter is roughly a yard. A kilometer is about 2/3 of a mile. And so the kilometer is much larger. And so if we're only talking about 1 meter, it's a fraction of a kilometer. So our answer should wind up being a number that's less than 1. We start out with our original quantity. We need to come up with a conversion factor. We want to cancel out meters. So kilometers will go in the numerator, meters will go in kilometers in the numerator, meters in the denominator. And so, is it 1,000 kilometers in a meter? No, it's 1,000 meters in a kilometer. Meters times meters cancels. We're left with units of kilometers or kilometers, and the answer will be 0.001 kilometers, or 1/1000th of a kilometer. You could also have written it as 10 to the minus 3 or 1 times 10 to the minus 3. They're all equivalent answers, unless the problem explicitly states to write it in scientific notation or in fixed notation, then you have the option.